if you look at your reference chart, it's in 3 sections. The top row of the second section is your double angle identities, and then the second row is your half angle identities. As always, I highly suggest when I say look at your reference chart that you literally look at it. If all you're doing is copying down what I'm doing up here, then you're not practicing looking at this, and you're not going to be able to find stuff easily on here. So for our double angle identities, for sine of 2 theta and tangent of 2 theta, we have one option. There's just one. But for cosine of 2 theta, we have multiple options, and it's really just this one, and then you can use the Pythagorean identity to make it into different forms. So basically, if we started with this, but we substituted 1 minus sine squared for cosine squared, then it would end up with this. Or if I started with this and substituted in 1 minus cosine squared for sine squared, it would simplify to this. So it's just a different way to write them. Okay, and we'll talk about how you can make a decision on which one you're going to choose and so forth. So let's look at number 1. It says if sine theta is negative 1/3 and theta is between pi and 3 pi halves, then we want to find tangent of 2 theta. So we don't care what theta is, we just want to double it and then find the tangent of it, basically. So if this tells me I know sine is negative, and then it says theta is between pi and 3 pi halves, we should be able to figure out which quadrant that is in. Which quadrant would that be? Alex. If the theta is between pi and 3 pi halves, what quadrant is that? The third quadrant, yes. Okay, so if I am between pi and 3 pi halves, I'm in the third quadrant, so I'm going to draw a triangle over here in the third quadrant. There's my angle. Sine is opposite over hypotenuse, or y over r, so that's going to be 1, and this is 3. That's a negative 1/3. So I got to figure out which one's negative. Well, the radius is never going to be negative, so that's a negative 1 right there. Then I need to figure out if I even need to know what the x value is. So when I go to find tangent of 2 theta, there's only one option. And so in order for me to find tangent of 2 theta, I'm going to have to know what tangent of theta is. That's what we have over there is theta. To find tangent, I need y and x, so I am going to have to find this. So what can I do to figure out the x value? Pythagorean theorem. So this is going to be negative 1 squared plus x squared equals 3 squared. So this is 1 plus x squared equals 9. So x squared equals 8. Oh, that's 8. So x is equal to plus or minus 2 square roots of 2. Then I have to decide if when I put my x value in here, should it be positive or should it be negative? What would it be for this one? Negative, because of the quadrant that we're in. That's why it matters where you actually are. All right, so we've decided we're going to use this. So I'm going to write down tangent of 2 theta equals 2 tangent theta over 1 minus tangent squared theta. And so in order to figure all this out, I'm going to need actual tangent of theta. Okay. And tangent theta is going to be opposite over adjacent, or y over x. So that's negative 1 over negative 2 square roots of 2, which is 1 over 2 square root of 2. Then when I rationalize, that is the square root of 2 over 4. So that's my tangent value. So then I'm going to substitute in what I have. This is going to give me 2 times that tangent theta, which is the square root of 2 over 4, over 1 minus square root of 2 over 4 squared. So that gives me square root of 2 over 2 in the numerator. In the denominator, I get 1 minus 2/16. So before I do anything else, I'm just going to make that 2/16 into 1/8. So then I have square root of 2 over 2 over 1 minus 1/8 is 7/8. Then I have a fraction and a fraction, so this is the square root of 2 over 2 times 8 over 7. That's 4. So that gives me 4 square root of 2 over 7, and that is tangent of 2 theta. What questions do you have? Anything? Okie dokie. So if I look at number 2, they give me a tangent value and tell me that theta is between pi halves and pi, and I want to find cosine of 2 theta. So if theta is between pi halves and pi, what quadrant is that in, Erica? The second one, good. So I'm in quadrant 2. So there's my angle. Tangent is opposite over adjacent, so that is square root of 7 right here and 5 right here. Then I have to decide which one is negative. Well, if I'm in quadrant 2, it's the x value that's negative, not the y value. Then I'm going to need to find the radius here. So I'm going to do Pythagorean Theorem again. Square root of 7 squared plus negative 5 squared equals r squared. 7 plus 25 equals r squared. So r squared equals 32. R equals plus or minus 4 square root of 2. So I'm looking for cosine of 2 theta. And so when I look at that one, I have multiple options here. So if I choose the first one, I'm going to have to find cosine theta and sine theta. So, and the other one, I'd have to pick one or the other, so it really doesn't matter. But if you take a little, I'm sorry, let me back up a minute. I got plus or minus. Since it's the radius is never negative, so there's 4 square root of 2. So if I want to decide, maybe sine is way easier than cosine or vice versa, if you take a few seconds to try and decide what to do instead of just jump in and doing, sometimes it helps you a little bit. So if I was going to use the one that just has cosine in it, then I'd have to use negative 5 over 4 square root of 2. So I'm thinking if I know myself and I know that I always mess up on the stupid negative signs, then maybe I'd avoid that one if I could, right? Can't always avoid something, and there's not always a decision to make. Sometimes you just got to pick one. But if I use sine, I'm going to have an extra square root in there, but I'm about to square it, so it really doesn't matter. So I think we can avoid the negatives. We'll just use the one that has only sines in it. So that means that cosine 2 theta is equal to 1 minus 2 sine squared theta. It makes absolutely no difference which one you choose. You'll get the same answer in the end as long as you do everything correctly. So that means in order for me to do this, I don't know what theta is. So I can't just double it, and I can't find it. I mean, I could find it with a calculator, but y'all hadn't seen a calculator in my hand in a long, long time. So that shouldn't be anything you're trying to use here anyway. I just need sine theta, and I can figure it out. So sine theta is an opposite over hypotenuse. That's the square root of 7 over 4 square root of 2. And I am not going to rationalize here. I could. It wouldn't be wrong. It's just not necessary because I'm about to square it anyway. You just have to make sure in the end that you're rationalized when you have a square root. All right, so I substitute in, and I'm going to get 1 minus 2 times the square root of 7 over 4 square root of 2 squared. So that gives me 1 minus 2 times 7 over. Now, when I want to square 4 square root of 2, that's something I should totally be capable of. But pay attention to what you're doing and where your stuff comes from. What is 4 square root of 2 squared? You shouldn't even have to think. You should have to do zero math. Where'd it come from? Came from right here, right? Where did I get that from? Taking the square root of that. right? So if I take the square root of 32 and get this, when I square it, it's 32. Make sense? So that way you're not having to think through it again. Even though you're capable of it, you ever make a stupid mistake on something easy? Yes, we're all capable of that. So that's just 32 there. But of course, if you can't read your own work, then good luck finding it, but there you go. So this is then going to be 1 minus 7 over 16, which is going to be 9 over 16. Can I reduce that fraction anymore? The answer is no. But the reason I asked that question is because sometimes when you're like reducing, you get there, I see weird things like 3/4, because you took the square root of numerator and denominator, right? Is that a legal way to simplify fractions? No. But again, sometimes just weird things happen, so make sure it's not happening to you. That's it, and that is cosine of 2 theta, and you're done. Any questions at all? All right. Oh, I'm sorry, go ahead. Well, I squared it. Oh, 2, I reduced it with the 32. That's where I got the 16 from. Yeah, so it's like 2 over 1, and I reduced it. Okay. Anything else? Alrighty, then let's look at the half-angle identities. So on the half-angle identities, sine and cosine have one option. Tangent has 3 options. And we'll kind of think through what the best option is on those as well. But if you look at the tangent versions here, which are the second row in the second section here, I'm thinking if I had to pick one I would like to avoid most of the time, it would probably be the first one because it's a big old yucky square root, right? But if for some reason I can't figure out sine, then I only have cosine, then that would obviously be the one I would have to go with. So let's look at how we're going to handle this number 3. It says find the exact value of each expression using the half-angle identities. So it's specifically telling you what to do here. I mean, once you really get the hang of this and you're applying it in other things, then you kind of know it might be something you want to use. But cosine of 3 pi eighths, that's not something that you know, right? I would think it wouldn't be. It's not something that I know. But if I think, and it's telling me to use it as a half angle, like right now, you're not going to have to think, ooh, I should use half angle here on some random number. I mean, it's telling you how to do it. So if I take 3 pi eighths and I say, all right, so my half angle, so theta over 2, because I took half of it, is 3 pi eighths, then I want to figure out what theta is. So just like anything else, to solve for theta, you would multiply both sides by 2. So that's going to give you that theta is equal to 3 pi fourths. Now that's an angle we understand, right? That's an angle I can find, sine, cosine, and tangent of, and whatnot. We agree with that? All right, so that's where these half angles come in handy. If you look up here, I want cosine of the half angle. In order for me to figure that out, I need cosine of theta in order for me to find cosine of theta over 2. Well, here's theta, and I can figure that one out. So this is cosine of theta, which is cosine of 3 pi fourths. And what is cosine of 3 pi fourths? Good. Negative square root of 2 over 2. Very good. So that's really the only value I need, and then I need to be able to use that correctly. So let's write that down. Cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta over 2. All right, so that's what I'm getting off my reference chart there. So when I go to substitute this stuff in, cosine of theta over 2, I know what theta over 2 is. That's 3 pi eighths. So cosine of 3 pi eighths is going to be equal to plus or minus the square root of 1 plus that negative square root of 2 over 2 all over 2. Everybody with me so far? Now, I have to figure out if it's plus or if it's minus. So that 3 pi fourths, I know what quadrant that's in, but that's theta. I need to know where theta over 2 or 3 pi eighths is. So if this is pi halves, that's basically 1/2 times pi, right? So 3 pi-8 is 3/8 of pi. So is 3/8 more or less than a half? Less. So that means I have to be in quadrant 1. Does that make sense? It's how you can reason around the circle. Like, you don't have to know exactly where it is, but you know it's going to have to be in quadrant 1. And since it's in quadrant 1, it's going to be positive for sure, and then we don't have to worry about the plus or minus anymore. Okay? So then I'm going to keep going. So now the rest is just basic arithmetic and fraction skills from 4th grade. So big old square root, got to make sure everything is under that square root. In the numerator, you need a common denominator of 2. So that would give me 2 minus the square root of 2 up there. The denominator is 2. So if I think about that as 2 over 1, then that's equal to the square root of 2 minus the square root of 2 over 2 times 1 over 2. And those of you that are not actually writing down the reciprocal when you're multiplying, some of y'all are canceling things out at the wrong places. So this is equal to the square root of 2 minus the square root of 2 over 4. Just like any time you take the square root of a fraction, you can take the square root of the numerator, you can take the square root of the denominator, and separately. So this is square root of 2 minus the square root of 2 over 2. That is the cosine of 3 pi-8. Okay. We good? What questions do you have? Anything? All right, now, really the square root inside of there, we should simplify that more, but that's not a skill that I think you've been taught at this point. And I'm not going to go into that here because it's not a trig thing, it's a radical thing, and I don't want that to add confusion because that's not technically part of the lesson. You with me? So it looks weird, we could simplify it, but we're not going to. Okay, as long as your denominator is simplified and rationalized, you're good. Right? Any questions at all? All right, let's look at another half angle. Eventually. There we go. All right, so they give us sine. They tell us that theta is between pi and 3 pi halves. And I want to find tangent of the half angle. So if theta is between pi and 3 pi halves, what quadrant is that, Atenas?
The third one?
Yes, ma'am. Thank you. So here's my angle. They give me sine. Sine is opposite over hypotenuse. And so this has to be negative. I can do Pythagorean Theorem here to find x, but this is a Pythagorean triple. It's okay if you don't know your triples. If you don't know your Pythagorean triples, then you need to know your squareds so that you can square 17 easily and get through Pythagorean Theorem quickly. But when you do, it's 15. And then since I'm in the third quadrant, it has to be negative. Okay. So when I look at tangent of the half angle, okay, I got 3 options there. Because I am capable of finding sine, I think I'm going to avoid the first one because it just has the yucky square root in it, okay? I mean, again, we could use it. There's nothing wrong with it. Of the other two, one's not necessarily better than the other, but I prefer it if my denominator had one term, if I have an option. So I think we'll go with that second one that has sine in the denominator. So we're going to do tangent of theta over 2 equals 1 minus cosine theta over sine theta. Now, if I did use the first one that has the plus or minus, I would have to be able to figure out what quadrant I'm in to know if the answer is supposed to be positive or negative. So here's how you do it on this one. So if I'm going to rewrite this, so if I have pi less than theta is less than 3 pi halves, so this is what they told us. They told us that theta is between pi and 3 pi halves. But I need to know where theta over 2 is. So if I want theta over 2, I can't just divide this one in half. I would have to divide all of them in half, which means that the half angle, theta over 2, is somewhere between pi halves and 3 pi fourths, which puts it in the second quadrant. And in the second quadrant, is tangent positive or negative? Negative. Okay, so that would tell me it's negative. So even though I don't have to figure that out on this one because I'm not taking a square root, at least I know now my final answer is supposed to be negative. And if it's not, I did something wrong. So it's still nice to know. Okay, so let's see what else we need. In order to solve this, I need to know cosine and sine. So from here, cosine theta is negative 15 over 17. And they gave me sine, so I'm good. So now we substitute this in. We get 1 minus the cosine, which is negative 15 over 17, over sine, which is negative 8 over 17. So in the numerator, I need a common denominator. So my common denominator in the numerator is going to be 17. So that would be 17 over 17 minus a negative, so that makes this 32. And this is a negative 8 over 17. Yes? Then that's going to give me 32 over 17 times a negative 17 over 8. So the 17s cancel out. 32 divided by 8 is 4, and I have this negative sign here, so it's negative 4. So I knew it was supposed to be negative, so that's good. Doesn't guarantee me that the 4 is right, but at least I got the correct sign. And that is tangent of theta over 2. Okay, what questions do you have? Alrighty. Then let's look at proving some of these. Number 5. So the left-hand side definitely looks more complicated, and I think I'd probably be better at substituting something in for cosine 2 theta at this point than getting it into that, since it's still fairly new. So we're going to work with this side. This is our goal. So the first thing I'm going to do is substitute for cosine 2 theta. So let me rewrite cosine squared theta minus. But when I look at my chart for cosine 2 theta, I have 3 options. So it will help me if I think about which one to use. And sometimes you'll think through it. Sometimes you make the not such a great choice. If I just randomly picked one and threw it in here, we could still finish this problem just fine. What would change? Our steps would look different, and maybe we'd have more, maybe we'd have less, who knows. But if I know my goal is sine squared, then it would be nice to get rid of the cosine squared, which means I think that I would not use the second one, because I at least want something with a cosine in it, right? But I also would like to have a sine left, so I think I'm going to go with the very first one. That seems to make the most sense in what's going to happen here. It's 2 terms, so I need parentheses. And this will be cosine squared minus, oh, sorry, I left off my theta. Don't leave off your thetas. Cosine squared theta minus sine squared theta equals sine squared theta. So cosine squared minus cosine squared, those zero out. Then I have minus a negative sine squared, so that's positive sine squared theta equals sine squared theta. And I'm done. Okay. Any questions? That one was really short and sweet. Okay. All right, so if we look at number 6, which side's more complicated is kind of a matter of opinion. But if you're thinking, I think I'd like to actually substitute something for sine 2 theta instead of trying to get it into that, let's make this our goal, and let's work with that side. So I'm going to write cosine theta plus sine theta squared equals 1 plus, and then sine 2 theta is going to be 2 sine theta cosine theta. Okay. So we can only work with one side at a time, and we chose to work with the right side, or I made you choose to work with the right side. Do you see anything that just jumps out at you that would make a whole lot of sense to do on the right-hand side at this point? I'm going to go with probably not, right? Now, I have way more experience with this than y'all do, so I can think outside the box and I can see something I could do to make that work. At this point, you seeing that and thinking about that is highly unlikely just because you don't have any experience with it yet, right? That makes sense. I mean, that kind of comes with experience to know how to play, be more comfortable with playing around with them and figuring it out. So what I'm saying is if you were to do it in this, even if you try to do some stuff on the right, chances are pretty good you're not going to be able to get it very easily to look like the left-hand side, okay? And so I pushed you down this road on purpose because this is probably what happened on some of those other ones. You're going to make some decisions sometimes and going to be like, I'm stuck. I really don't have a clue what to do here, and that's okay. So instead of just staring at it or giving up, let's go, that was maybe a bad decision. So instead, let's try going the other way. Let's try making that our goal and working with this side, okay? So on the left-hand side, when I square that, I don't get cosine squared plus sine squared. That's not how algebra works. Instead, when I square that, I get cosine squared theta plus 2 cosine theta sine theta plus sine squared theta. Why? Because algebra. And that equals 1 plus sine 2 theta. Okay? So it definitely made it look yuckier. So now when I look at that left-hand side, I got some squareds. And when you got some squareds, what's the first thing we've been looking at on this chart? Pythagorean identities, right? So do you see something we could use Pythagorean identity for here? Yes, good. The cosine squared plus sine squared, that's 1. So I get 1 plus 2 cosine theta sine theta equals 1 plus sine 2 theta. All right, so then on the left-hand side, this looks kind of familiar, right? And on the chart, it says 2 sine theta cosine theta, but is that the same thing? Because we can multiply in any order. It is. So this is 1 plus sine 2 theta equals 1 plus sine 2 theta. And just FYI, to think outside the box up here, we could have substituted cosine squared plus sine squared for 1, but then we also would have needed to rearrange the equation so it was something we could factor, and then we could have factored it and put it into that form. I mean, that's how you would work with the right-hand side, basically. Okay, we good? Okay. Any questions? All right, let's look at number 7. Which side looks more complicated here? The right side. I agree. I think we probably all agree with that one. So this is our goal. We're going to work with this side. So I'm going to write down tangent theta equals, so I'm going to do 1 minus, now that cosine 2 theta, I got 3 options. And I want to be able to think about it, but in order for me to really think about it, I need to know what my denominator is going to look like. So I'm going to go ahead and substitute in that sine 2 theta. Right off of here, I get 2 sine theta cosine theta. Okay. So, and I want to think about what my goal is. My goal is tangent, which I know is sine over cosine, which I have a feeling is going to come into play here, given that I've got sines and cosines on the right-hand side, which means I'm going to need to get a sine out of the denominator. So when I look at my choices, I'm definitely going to have to use either choice 1 or 2 so that it at least has a sine in it, right? I would like to not introduce another cosine in the numerator, plus I'd like to get rid of this 1. So if I look at just the second one, that 1 minus 2 sine squared, that one looks the most promising. So it's 2 terms, so I'm going to put a parentheses. 1 minus 2 sine squared theta. So then that means I get tangent theta. And again, had I just randomly picked one, closed my eyes and pointed and picked one, I could substitute it in, and then I could still finish it. It's not like this one is the right one and the other ones are wrong. It's just be different. So 1 minus 1, those zero out. That's nice. Then I have minus and negative, so that's plus. So that's positive 2 sine squared theta over 2 sine theta cosine theta. So then I can reduce these 2's. Then I can cancel this sine with one of these. That leaves me with sine theta over cosine theta. And so then that's tangent theta equals tangent theta, and I'm done. What questions do you have? Anything? All right, so on the last one, would you agree that the right-hand side looks more complicated? I think so. So I think we're going to use this one. This is our goal. This is one we're going to work with. So get sine 2 theta. I would like my denominator to be one term most of the time, not all the time, because there's times where I don't want that. But I feel like there's something I can do with that 1 plus tangent squared. What could I replace that with? Secant squared, very good. So I can replace that with secant squared. Then in the numerator, I have 2 tangent theta. So since there's a sign on the left-hand side, and I have quotients and reciprocals on the right-hand side, I think now is when on the right-hand side, I'd like to make everything in terms of sine and cosine. So I'm going to get sine 2 theta equals, the numerator here is going to be 2 sine theta over cosine theta. And then the denominator is going to be 1 over cosine squared theta. So then fraction and a fraction, this will give me 2 sine theta over cosine theta times the reciprocal of the denominator, so that's cosine squared theta over 1. This cosine cancels with one of those. So that gives me sine 2 theta equals 2 sine theta cosine theta. Does that look familiar? Yes, you can go look on there, and that is sine 2 theta. So sine 2 theta equals sine 2 theta, and we are done. Okay. What questions do you have? Anything? Okay, so another reminder, makes me a little sick to my stomach that I have to say this when you've been in school this many years, but I'm not up here to put on a show. If I did, it'd be way more exciting. But I'm not up here to just show you how to do things so that you have something to write down. I'm having you write it down so that when you take it with you, you have something to look at. So use your notes when you're doing your assignments, if you're not already doing so. I know a lot of you are. Probably preaching to the choir for some people. But that's why we take them, so you have something to look back at and that you can follow them. So make good use of them. I promise you, you will be glad that you did. All right? So no questions about anything? All right.